How's it going? We are the Integrated Health Management Systems. My name is Mike Cika, this is Brian Neel, and Kurt Jordan. We're going to start by giving you a little summary of our project and why we chose this as our senior design project, and then we'll get into a little logistics of the actual hardware we built. So first thing we wanted to do was we were in contact with the Ohio University College of Medicine, and we wanted to come up with a solution because health rates in America are very poor. Obesity rates are high, and a lot of people don't simply know that they're unhealthy. They're too afraid to go to a doctor, or they're too embarrassed to actually have their health checked up and see their weight and have others see those statistics. So the idea was a kiosk that a user could come, sit down at, get their vitals. It's non-invasive, and what will happen is those vitals will be pointed out to them if they are at risk. So they can see, if they're at risk for high blood pressure, hypertension, if they're obese. And when these risk factors occur, the OU College of Medicine wanted these to be pointed out to the user so they can contact a physician, or it can be integrated to where a physician can be directly contacted from the kiosk. Now, the problem that arose from this solution and why we are integrated into it is basically the cost. We wanted to come up with a cheap and affordable way to make this happen. Current market kiosks range anywhere from $10,000 to $30,000. They have parts that need to be FDA approved, and all this time consuming diagnostics. If a scale breaks, they have to completely replace a kiosk. So what we focused on was developing a scale that could be integrated into one of these kiosks and an interface that will have data storage. So I'm going to take it, Anthony's going to take over here and basically give you a little more rundown.
Okay, so after researching the project requirements, we had to decide on how we could help the College of Medicine distribute these kiosks more efficiently. So we decided we were going to start by focusing on the scale, and we're going to build a scale from scratch that'd be much more cost efficient than the ones that they're currently using. And then we're also going to focus on the software side, because the current kiosks they have don't have any database storage, which they need to be able to store the statistics that they record. So from the project, we then decided how we're going to build our scale. We decided we wanted to use this cheap, high-impact plastic that was going to be very durable and easy to manufacture. We milled all of this from scratch on our own, and we had no previous milling experience. And then we also use aluminum as our feet, which make this depression mechanism so that our strain gauges will be able to change and the resistive properties, which changes to a change in voltage, which we can read and then convert that to a weight. So Kurt will go into a little more detail on how this process works.
The main thing that we're using here is a Wheatstone bridge network for the feet. There's 4 different strain gauges on each foot that is then read into a pick via an op amp. Each foot is read 4 different times and then averaged out before it is summed up. The scale itself is showing in each corner currently each individual's foot reading. So you can see that it's outputting the actual number value, showing the differential between how it's reading right now. In the center of the scale is the total weight right now. So it actually will center out and balance out, and then actually take the reading as you push on it. The circuit board was all developed internally by us. It was first laid out on a schematic and then built into the actual printed circuit board, which we populated in-house. The best feature about this is each foot can be replaced on its own. If one would fail, you can take it out and put it back instead of having to send away the entire unit that could take 3 to 5 weeks. The price range for all this stuff is about $150 compared to a normal scale, which would be anywhere from $300 to $1,000. And Mike will wrap it up.
So basically, we have the scale, and like I said before, we wanted to have an interface that could tie in our scale, so when a user stands on our scale, they will see that weight populated on the screen, and they can see if they're overweight via their height that they entered. And basically, the interface that we designed has a flow chart similar to what you would normally see at any login. You can log in, you can create a user, you can use the scale anonymously, And basically what will happen is once the user creates a username, they'll be able to log back into the software that we designed and see previous health checkups, if they were at risk, how they can prevent these risk factors from occurring. And that data is all stored in a database, and that can be distributed to local doctors and physicians' offices to see that data. In conclusion, Anthony will talk to you a little bit about some of our future work.
Okay, so our deliverables for this project, we got our scale, which it has to be able to weigh up to 400 pounds. It's going to be easy to do diagnostics on because of the LCD screen and the debug mode that it has. It's going to be easy to redesign and manufacture different parts, and it's going to be easy integration into our user interface. Our user interface will have server-side database storage, and it'll have a graphical display for all of the user's data. Some future work, we still think there's a couple improvements we can make to the scale. We use aluminum, and we think that maybe a spring steel might give better results. And we still need a web interface for the users to be able to go on the internet and look up their past history. So in conclusion, the health management kiosk is a low-cost health information system. It will be a very good asset to the community, and we're privileged to help OUCOM in getting their goals across. So that's our project.
We're going to give you guys a quick demonstration of what an actual use of our scale would look like. So right now it's capable of weighing up to 400 pounds. It's durable, high-impact plastic. Now, right now the values that are showing on the screen are in hexadecimal. They still need to be tuned and calibrated, but that's going to require some correct weights. We need to get up to 400 pounds accurate, so we needed a 400-pound reference that's completely accurate. And that's basically the process we're working on right now. As you can see right now, it's ready to be used.
This is a demonstration on how each of our feet work. Here's a sample foot. You can see there's two strain gauges that take readings on the flux in the metal. When you press in the metal, you get a change in voltage, which that's what we convert into a weight inside our scale. So that's a simple demonstration of how our feet work.